Hello, assalamu alaikum.
Alaikum salam.
Bismillahirrahmanirrahim. Okay, we approach to the end of the chapter number 4, and we do the last small topic called interpolation with Spline. Up to now, we did interpolation with the help of Lagrange polynomial and with the help of Newton polynomial, and we approximate the function with some degree, higher degrees from degree 1, 2, 3, 4, 5, 6, like that one. Now we have the last topic, interpolation with the Spline function. This is sometimes we also call the piecewise polynomial approximation. And what is the simple meaning of this one is what? That means we apply the linear interpolation, which we already did. We apply linear interpolation in the case of Lagrange polynomial, in the case of the Newton polynomial. And when we apply linear interpolation, we need only 2 points, x0 and x1, selecting the best point with the condition that interpolating points must be inside the interval. And then we do the things and we got the answer. And okay, now what we have to do here in the case of the Spline function, that means we have to apply the linear interpolation formula in subinterval. All the interval, possible interval given, we have to apply each interval, we have to apply the linear interpolation, and that we call is a Spline, linear Spline. So if we have a 4 point, 4 point mean we have a 3 interval, and 3 interval mean we have a 3 Spline function, S0, S1, S2. But that Spline, as I told you again, simply mean you have to apply the linear interpolation. So this is your choice. Either you use linear Lagrange formula to find first Spline, second Spline, or third Spline, whatever Spline we need, or you apply the linear Newton polynomial. But in the book, I apply linear Newton polynomial and also the linear Lagrange. So same thing that you can do. What is the definition of the linear Spline function? Spline function we can have in the different shape. We can have a linear Spline. We have the quadratic Spline. We have a cubic Spline. But in 254 course, we have only simplest case, which we call is a linear Spline. And the linear Spline mean we should have the degree 1 Spline function of degree 1. And what we have here now, we are given, for example, we are given n plus 1 point, and n plus 1 point mean first point I show by A and last point I B. And when you have n plus 1 point, just means you have a n interval, n subinterval, then each interval you have to apply linear interpolation. Right, this is the only things we have to do in that case here. And linear Spline function, when we say the function is a Spline, it must be the linear Spline, it must be the continuous at the inner point of the interval, and must be the degree 1. We have this one. This is, I mentioned, piecewise linear interpolation. That means we are given, for example, how many points we have here. I use 7 points. It means we can have a 6 different interval, and then each interval we have to define linear interpolations. First, x0 to x1, we have a new Spline, x1 to x2, second Spline, x2 to x3, next Spline, like this one we call here. And this is a formula we have here. You remember, if this formula, generalized case, this is we call is a Spline, linear Spline. But as I told you, not in the 1 interval, so in k interval. So therefore, I'm writing not is a k1 we can have here now. This is your, remember, this is your what? This is your L0. This is your f of x0, right? This is your L1. And this is your f of x1. But in the form of now, in place of x0, I'm using what? F of xk, and in place of f of x1, I'm using f of xk plus 1. Exactly the same meaning we have here now. This is linear Lagrange formula, and linear Lagrange formula can be also written in this form. And if you remember this one, what is this one? This is a Newton polynomial form, Newton polynomial. So either you apply this or this is the same. First I use this one and I call this one as a, this is the f of xk, and I call this one is ak. This one, the first order dd, which I call bk, and into x minus k. And what is the interval you have for this one? Your interval is from xk to xk plus 1, where k is running from 0, 1 to 2, and we have here now. So this is the only things you have here now. You have to calculate ak and bk for each subinterval, and then use the find here. For example, when you put k equal to 0, what you have, s0x is equal to a0 plus b0 x minus x0. What is a0? Why a0 mean y0? Y0 mean f of x naught. And the same, what is b0? B0 mean f of x1 minus f of x naught, same by x1 minus x naught. So exactly the same thing we can have here now for k equal to 1, 2. So we have this one. Let's take the simple example for this one. As I say, when we say your function is a linear subline, it should be degree 1, which is okay here, the degree 1. And it must be continuous at the inner point. Your big interval is what? 0 to 3. And what are the inner point? We have 1 and 2, right? So it means when we say the function is a linear subline, it must be continuous at the inner point of the interval. So it means the question is what? He said find the value of the coefficient AB such that the following function is a linear subline. So this is already given the linear subline here, but there are unknown we have, so we have to find out. So you can see how can you find out? We simply use the function is continuous. X is continuous at the inner point. Inner point are 1 and 2, so S must be continuous at 1 and 2. You remember in math 150 what mean continuity? Continuity mean function must be continuous at the given function is defined in the interval, which is we know it's a linear part. And the second one, that left limit must be equal to the right limit. That means limit must exist. So you can say the linear subline is mean limit exists. So we can limit exists mean the left limit must be equal to the right limit for the case 1. Left limit and the right limit must be equal to the case of x is equal to 2. So when we have the left limit for x approach to 1 from the left side, but it's basically meaning x is less than equal to 1. When x is less than equal to 1, what is the value of s? Is a minus x, which I write here. When x is approach to 1 from the right side, it means x is greater than equal to 1. So x is greater than equal to 1. What is your s? Is it 3x? And they are equal. Because why they are equal? Because he already defined that it is a linear subline. So then you can put x is equal to 1 and you can have here this there, and this give you the first equation. And the same you behave like in the second case for the x is equal to 2, because inner point continue to hold. Then say when left limit for x2 is x less than equal to 2, x less than equal to 2, what is the value of s of x? Is it 3x minus b? And when x is greater than equal to 2, what is the value of h? Is it 2x here? So we just write here. And now put the value 2 is a 6x minus b, and we have this one, which simply give you b equal to 1. And b equal to 1 mean b equal to 1 mean a equal to 3. So these are the point, and your subline function is this one, is a linear subline. And in exam, teacher can give you in the reverse way. Reverse way he give you here, and he say, check this one is a linear subline or not. So first you say that s is a degree 1, right? And second, you have to show s must be continuous at the inner point, which is 1 and 2. Check left limit, right limit for 1 and 2. Then if they are equal, then you say continuity hold, and continuity hold give you the second condition for the linear supply, and then you say it's okay. That's a proper example. How can we have the question in the exam? He say like this one. You are given interval. Find the linear supply which interpolate the following data. This is the first part. Linear supply you have to find. How many supply you can find out depend on the interval. How many interval you have? This is your first interval, right? This is your second interval, and this is your the third interval. It means you have to apply linear Newton polynomial or linear Lagrange polynomial 3 times. First time, x naught is 1, x1 is 2. And then you apply the same thing here now. And you have to do what formula I give you. This is the formula I give you. This is the formula, and you need AK plus BK. So it means you need K running from 0, 1, and 2 because you have 3 sublines. So K is 0, you find first subline, and K equal to 1, you have second subline, and K equal to 2, you have a third subline because you are 3 intervals, so you have 3 sublines. So first you put K equal to 0. So what is a K equal to 0? You have S0 x is equal to A0 plus B0 x minus x naught. And we know here I calculate the value. What is A naught? Is Fy0 or Y0 mean f of x naught? What is f of x naught given? F of x naught is given 1. And A1 is what? F of x1. F of x1 is given. And f of x2 given y2.5. And A3 mean f of x3, which is 3x3 equal to 4 here. So this is we have the file. Now you have to calculate the same way with b values. What is your b? Is a f of x1 minus f of x naught taken by x1 minus x naught. And you know what is f of x1? This f of x naught is this one, x1 is this, x naught is this one. So you use the value, and same way you can find out b1 and b2. So you have a new shape of the linear Newton polynomial is this one after putting the value. This one we call the first linear subline. Here you are, this is A1, this is B1, and you have the second subline here and the third subline. So we have 3 intervals, you have a 3 sublines. So each interval you subline, find the subline, first interval from 1 to 2, second from 2 to 3, and third from 3 to 4. And when you find the subline function, you can easily check this condition. Where is that one? This condition must hold. Wait here, what condition that mean here? Condition, this one. The value of subline at xk must be equal to f of xk. If not, it means something wrong with your calculation. But here you can have here, when you find the value of subline, this is the things we finish. So he said find all the sublines. So you have 4 point mean you have a 3 interval. So you should have a 3 subline function, the linear interpolation. This is the linear polynomial you have here now. Because subline mean the linear polynomial for each subinterval. Then the second part, he say, find the approximation of y at 2 over x plus 1 at this point using the subline function, suitable subline, the best subline. So you have the subline, this one, from 1 to 2, 2 to 3, 3 to 4. And now you have to approximate the function with the help of the subline. So you have to look what is given. Interpolating point given is 2.9. So you have to check 2.9 in which interval? It is this one. It means your best subline function is what? The S1. So you use S1, and that will give you the jawab of the problem. And the third part, he say, find the the error, absolute error, and absolute error is exact. And exact is what? Exact is what? Approximation of the function at 2.9. So you put 2.9 plus 1. This will give you the jawab is this one. And approximation is S1 2.9, which you just find out the point. And you have a very good jawab. Absolute error, as I told you, linear interpolation generally not give you the good one. But here you say you have a very good accuracy, 10 minus 3 accuracy. Just we use the linear interpolation. That's the thing here. That's nothing. This topic is nothing because this topic means you have to apply the linear interpolation in not one interval, more than one interval. But sometime maybe exam teacher give you this question. He say for the following table, find the value of y at 2.5 using the best piecewise linear spline. So it means you don't have to create all the spline because teacher never say. Teacher say only this. That means this is a simple case of the linear polynomial, which we discussed before the linear neutron. So what you have, only you have to choose 2 point, define spline or linear interpolation, and 2 point, you have to choose which one, where 2.5 majud. So that's the things you have, and you use spline function. This is a jawab you have here. This is not 225, this should be 2.5 here, because your x is given 2.5. This is 2.5, and this is the jawab you have. That means the linear spline. And we finished chapter number 4, and chapter number 4 mean we finish the material for second quiz. And your second quiz will be, inshallah, chapter 4 complete, and chapter number 3, I just go from here. Chapter number 3 should be from here, because before this one is iterative method, which we already discussed. We already discussed in the midterm exam. So your second quiz material will be error in solving the linear system from the chapter number 3, which is a conditioning the system and relative error, 2 topic only here. And chapter number 4 is a complete we have here now. And if you have the syllabus, which I may send you, that the second quiz will be the 13 week, but they change the department. When I say department, basically I mean your department also, because all the date will come from the engineering department. They changed the date for the second quiz. Now second quiz shifted from 13 week to the 12 week. Now you have a second quiz on 12 week. This is, we are in the 10th week. Next is 11. And after that one with the 12 week, you have your second quiz. And it is on Tuesday. And the timing is from 8:30 to 9:30. So you have a 45 minutes, same thing, 45 minutes. And most probably we will start at 8:30. So you have to finish how much? You have to finish 9:15. And you have the same 8 questions, and each question has 1.25 marks. Right? I will send you, inshallah, the date of midterm and the timing maybe very soon to you. But that's the things here. So your second quiz will be in 12 week, not in the 13 week, please. Right, any question you have? No, always, because you never talk in the Mahadra, because half of you are sleeping. Now we have a chapter number 5. Chapter number 5 is a very simple chapter. It's a numerical differentiation and the integration. Numerical differentiation means we will find approximation of the function at the, applying the approximation of the derivative of the function at the given point. And then we find approximation of the integration case. That means definite integral. That's we have a 2 part. This you already discussed before, but inshallah we discuss in detail like this one. We start the first topic is a numerical differentiation. That means we will find what? In this part, we will find approximation of the derivative of the function at the given point. This is your alpha now, the exact solution. So that's the things we have to do. We have to find the approximation of the derivative of the function at the given point. And for this one, we have to use some numerical rule. You know, this is what? This is the exact formula you discuss in math 150, the derivative of the function. But the jawab of this one is a function. But as I told you, we never find jawab in function. We always find answer in the form of number. So therefore, we find the derivative of this one at the given point. And for this, we have to use numerical rule. Many numerical rule for the numerical differentiation available, but we use two rule, and we will also look for the approximation of the first derivative and the second derivative in this part of the chapter. First, we look for approximation of the derivative of the function, the first derivative of the function at the given point. And for this, we have to use two rules. First rule is called the 2-point rule here, the 2-point formula. Here I prove the formula, but no need to prove here. And this is the formula you have to remember. This is called the 2-point formula. But I give you the background. You know what is this one? This is a linear Lagrange formula. And if you take the derivative of linear Lagrange formula at the given point x naught, inshallah, you will end with this formula, which we call 2-point formula. F of x naught plus h minus f of x naught divided by h here. Now, what is h here? You remember in chapter number 5, we talk about the data point. Data point, when I say, I simply mean the x value. And as I say, data point may be equally spaced, may be unequally spaced. But please remember that one in chapter number 5, our data point should be equally spaced. This is the point you have to remember first. But in exam, teacher give you many points and not equally spaced. You have to pick, for example, if you have to pick some point, it should be equally spaced. For example, you are given points is 1, 1.1, 1.5, 1.6, 1.6, 1.9, and 2. For example, this is given to you. And the question is, you find the derivative of the function at 1 by using the formula, and that formula need 3 points. One already given by the teacher, and the 2 other points you have to use, but that 2 other points must be equally spaced. Which point you will choose, please? Anyone?
1.5 and 2.
1.5 and 2. This is only difficulty. Here a student choose the wrong point. They choose the 2 other points, 1.1 and 1.5, but this is wrong because this is not equally spaced. So data point which we need in the chapter number 5 must be equally spaced, but when teacher give you the table, it is not equally spaced, but you have to pick only the point which you need should be equally spaced. Right? And for example, this is another things I give you here. This is 1.3, okay. You find the derivative at this one, and you need the 2 points. And that 2 points should be equally spaced. Now, in this case, you can have, I think you have a 2 option. What is one? One option you already mentioned, 1 and 1.5 and 2. And your H is what? 0.5, right? When you choose 1, 1.5 and 2, H is your 0.5. But you also have the second choice, which is equally. You can choose 1, 1.3, and
1.6.
And you have H is what?
1.3. 1.3
is a 0.3.
Yes.
So here you have to do what? Select the equally spaced point. This is first condition. And the second condition, see, the point you choose give you the smaller value of H. Smaller the value of H, better the approximation you have here. So that's the way you have to choose. This is only difficulty. Otherwise, nothing in this chapter. That in chapter, simply use the formula and you have the answer.
Doctor.
Yes.
Can I use 1.3 and 1.6 and 1.9?
No. For example, you need 2 points.
Okay.
So 1 is given, 2 points you need more.
Okay.
So that means you can use 1.3 and 1.6 here. And also the case we can have here, 2 points we can choose on the right hand side, 2 points we can choose on the left hand side, 1 point we can choose on left, 1 on right. This is 3 possible formula way, but later we discuss here. Up to now, you have to understand if you need any point from the table, that point should be equally spaced, you have to pick. And the condition to pick, smaller the spacing between them, better the approximation we can have here. This is called the 2-point formula, and for this 2-point formula, we can have f of x naught plus h, x naught plus h is equal to what? It simply means x1, because you have a 2 point. And when you have a 2 point, points are what? X naught and x1. And distance between them is h. So it's mean, what is the formula of h? What is h equal to?
X naught.
Minus?
X naught.
X naught. And from this formula, I can find the value of x1. What is the value of x1?
X naught plus h.
X naught plus the h we have here. So 2-point formula need 2 points, x naught and x1. H is a distance between them. So this is x1 and this is x naught, but I replace x1 in the form of x naught because you are given x naught. You know h. So directly you can find the formula this way. This formula is sometimes also called 2-point forward difference formula. 2-point forward difference formula. 2-point forward difference formula. Why we call forward difference formula? Because you are given what? You are given x naught. And you need one more point. And that point is x1. And x1 is on where side? On the right hand side. The right hand side means the forward difference formula we have here. If your h is positive, sometimes we call is a 2-point forward difference formula. But if your h is negative, negative mean if you need, you are given x naught. For example, you are given this one now. The table is given like this one. X minus 1, x naught, and x1. This is given always x naught. If you need x1, this is called forward. If you need 1 point on the left hand side, this is called backward difference formula. This is a simple case you have here now. So we can have, if you replace in h by minus h, your forward difference formula can take this shape, and this shape is called the backward difference formula, 2-point backward difference, the formula we have here. And what is the error term? I give proof the error term, but you don't need the proof here. I give the error term here. So this is forward difference formula, right? And this is its error term. This is its error term. What is the error term? Minus h by 2 second derivative at eta. What is eta? Eta is unknown point used inside the interval, and your interval is what? x0 to x1. And your x0, x1 always equal to x0 plus h. And this is formula is called the backward difference formula. And this is its error term. And its error term is what? H by 2 second derivative at eta. But generally, we use forward difference formula. If teacher say use 2-point formula, always use the formula. But if in exam teacher give you this table, for example, let's say you have minus 0 point, the 5, you have 0, 0.6, and 1. The question is, find the derivative of the function at 0. Find the derivative of the function at 0 by using the best 2-point formula, which you will use, please. This is 2-point formula. This is forward, this is backward. Which one you will use here?
Minus 0.5 and 0.
Because I told you, the smaller the h, if you want to use forward, you need on the right hand side of 0, which is what? 0.6. What is h? 0.6. But if you use this one, what is the distance between 0 and 0.5? Is a 0.5. Smaller the h, better the approximation. It's mean the best formula, 2-point formula, is the backward difference formula. So this is the things we have to, but remember that one here. Rest is nothing here. Let's take this some example here. If example, let's start with a simple example. I give 2 times this one to the exam here. I say f of x is equal to x cubed, which is defined in the interval 0.2 and 0.3. Use the error formula of the 2-point formula. What is the error point of the 2-point formula? Is this one, right? Formula for the approximation of f dash 0.2 to compute the value of the unknown point eta. You know what is the error formula? This is the error formula of the 2-point formula, minus h by 2 secondary. This is, I put it complete, but this is the error formula. Error is what? Exact minus approximate, right? And this will give you the possible error. Now, if you can see, he say in the question, find the value of eta. Eta is what? Eta must be measured in the open interval. So when you find the eta, you need first to find exact value at x0. Then you find approximate value. This is your left hand side. Then you work on the right hand side. Your function is given. Take the second derivative of the function at eta. H is given. And you simplify. You have the value of eta. So first I find out the exact value. What is your x0 given? 0.2. What is your h, please?
0.1.
0.1. H is the difference between the point. This is x1, this is x0. So x0, x1 minus x0 is your h. So you have h is equal to 0.1. So first you find out what is your exact value at 0.2. This is your first derivative of the function. Find the first derivative at the function at 2. This is your alpha in chapter number 5 here, derivative of the function at the given point. And then you find out this is your exact value. Then you need the approximate value, and we know approximate formula for this one is this, is f of x1 minus f of x0 taxim by h. Your f of x1 is 0.3, f of x0 is f of 2, h is 0.3 minus 0.2 is 0.1. What is f of 0.3? Put 0.3 here. You have 0.3 power 3 minus, what is f of 0.2? 0.2 power 3. We have this, h is this, and this one you will get, inshallah. This is your approximate. Exact minus approximation give you what?
An error.
Error.
Exact.
And that you have the exact error here. This is on the left hand side. And you have to solve the right. This is, you know the value of this one, you know the value of this one. Now you use the right hand side to find the value of eta. So what we need? We know h is 0.1. What is the second derivative? That's we have to calculate it. First derivative is this one. Second derivative is what?
6x.
6x.
So we find in the eta. So second derivative is what? 6 eta. So what we have? The left hand side is the error, which you already calculate, this one. And then the right hand side is what? Minus h by 2. Second derivative at eta. H is 0.12 and second derivative at eta is 6 eta. Now you can easily take this term with 6 on the denominator and you can have the value of eta. And when you simplify, inshallah, you will get the jawab of eta. And eta jawab must become between 0.2 and 0.3 because this is a condition given. Eta is what? Between x0 and x1. If it is not coming this one, something wrong with your calculation. But alhamdulillah, we have this one. So many times teacher can ask you, use the error formula to find the unknown point eta. So that means this formula you have to use, and this formula to use this one, you need to solve the both sides, left-hand side and the right-hand side. Left-hand side, you need two things, exact value and the approximate value. And the right-hand side, you only have to take the second derivative of the function at the given eta point.
Doctor, I have a question.
Yes.
I'm not really sure how did we find h.
H you have,
Yes.
because your interval is this one, right? And I told you, what is your interval for 2 point? 2 point mean interval is x0 and the x1.
One, yes.
And what is the relation between them? H always equal to x1 minus the x0,
Okay.
right?
Yes, okay. So
This
it's
is the
0.1.
Yeah, so 0.3 minus 0.2 is equal to what?
0.1, yes.
Yeah, that's the things we have here, right?
Okay. Thank you.
Okay, let's see, we have the complete example. And as I told you, generally we find the error bond. What is the error bond we have here? Error bond mean the absolute sense, right? And absolute sense mean the absolute here and absolute here. Absolute of minus go h by 2 and second derivative. And we know what is the second derivative absolute sense. We always say maximum value of the second derivative inside the interval. That is your error bond. Now we have a complete question, please. Example number 5.2. And he said, let f of x is equal to x cosine x minus x square sine x, and h is equal to 0.1 and 0.01. In the exam, teacher never give you 2h. I just give you 2h because I want to show you if you have a smaller value of h, your error must be less. because if you have a smaller h, your jawab approximate answer always good one. And when your approximation is good, it means your error is small. But in exam, teacher always mention you what? 1h here. Let's we do here. He say using 2-point forward difference formula, and we know 2-point forward difference formula is what? Over 2-point formula, forward difference is what, please? It is f of x naught plus h, I'm right? Minus f of x naught taqseem by dh. What is your x naught given? Is a 1. What is h given? Let's we choose first h is equal to 0.1 here. And then what we have here, f of x naught plus h. So this means 1 plus 0.1 is 1.1 minus f of 1 taqseem by 0.1. So what is f of 1? In place of x, put 1.1. So we have this one, 1.1 cosine 1.1 minus 1.1 square into sine 1.1 minus f of x naught is 1 cosine. So we have this one. Use calculator and inshallah you will get, this is the answer. And then in place of h, you use h is equal to 0.01. So then you have 1 plus 0.01. So which is this one. I use your function value and inshallah you will get this, and use calculator and you have the jawab is this one. Now you want to say this is the jawab for h is equal to 0.1. This is the jawab for 0.01. Which one is good? Of course, you can only say which one is good when you know the exact solution. And what is the exact solution is f-1. This is the exact solution. So you need to find the first derivative of the function, and the first derivative of the function is this one. And you find the first derivative of the function at the given one, which is 2.4.
2.5, yes.
Yeah, so you can see which one is close.
The second one.
Second one
Yes.
should be good, because second one we are using h is equal to 0.01. So therefore, as I told you, when you pick the point, because for 2-point formula, you don't pick the point. You have to select very next point on the right-hand side. But the problem comes when you have to pick 2 points on the right-hand side or the left-hand side or the one left on right. That we will do in the second numerical method. And that is a tricky one, but 2-point formula is a very simple one we have here now. Then he said that compute the error bond. This is the error formula, and this is in the error bond sense here, because we know the absolute here. We know h here 2 or no, only we need second derivative of the function, and we have to find the maximum value of the second derivative is the value of second derivative eta x here. So a function is given this one, and inshallah first derivative already we know, and the second derivative you can find out, which is this one. Then you find the second derivative of the function and look in the interval. Your interval is what for this case? What is your interval for this case, please? When h is equal to 0.1, what is your interval?
1 and 1.1.
1 and 1.1. And what is the interval here? 1 and 1.0? 1. So this is in the first case we have, and we have, this is the approximate value. And for this maximum is the same here, because the maximum is used at the smallest point is 1 here. Then when you find out the error bond, we know h by 2, h is 0.1, and m is this one. This gives you this jawab. Here you have error is big. Why you have error big? Because your h is 0.1. And here you have h you are become 0.01 in the second case, and which is this, and m is the same value, but your jawab is this error is better than this one. This is how can we do the 2-point formula with the help of this one. This is I also solved with the help of backward difference formula. No need for that one, but I solved the backward difference formula also. Next time, inshallah, we do example number 5.3 for the 2-point formula. But for the 2-point formula, the good example, if you will ask me which one is good one, so 5.1 and 5.3, these are the good example from 2-point formula. If any example come in the exam from 2-point formula, either 5.1, which we finished for the error in, find the value of eta by using error formula, and this is the things we have to. We do this one, inshallah, next time. Right?
Inshallah.
How you did the exam, I don't know.